Hello. Let's take a look at Leetcode 647 Palindromic Substring. We have been given a string and we are asked to return the number of palindromic substrings in that string. It's also said that a palindrome is a string that reads the same way backwards from forward, right? We've been given example like ABC. Now A reads same way backwards and forward, B and C, right? And then if we want to check all of these three at any point on this index 0, 1, 2, when we get here, we set up 2 pointers, right? And the left and right pointers starts at the same index point for each of them. So here, the left pointer will move here, and then the right pointer will move here. If the strings at the left and right pointers are the same, then we have at least a palindrome that starts with 3 letters, right? So here, that is why A stands alone. A is on its own is a palindrome. B on its own, C. But if we should pick, say, B as the center and spread out, here we have A and here we have C, so it is not a palindrome. So from this we can only get 3 palindromic substrings. And then we've been given another example that says A. Both A's on themselves, by themselves alone, is a substring, right? It's a palindrome. So that is 1 by itself. Standing alone gives us 3. Right, so we have that, and then each pair gives us a palindrome, so that is +2. And then, as I described earlier, right, if at any index, for example this index, the right moves here and the left moves backward, we are going to get A at a standalone, A at the right, and A at the left, and it reads backwards and forwards, right? So that gives it another one that makes it 6. Now, earlier on I described A being a palindrome. How do we get that? Now, for this one, even though we start at any point, we are treating that index position as the center and then spreading left and right. But what if the left and right pointers do not start from the same point? So in this case, the left pointer and the right pointer do not start from the same position. That is why we are having a palindrome, because left is equal to right at this point, right? So first of all, we treat a single index at the center and spread out, and we also check when we don't start both left and right from the same position, right? So those are the 2 scenarios where we would run to try to determine whether a palindrome exists or not, right? Another way I try to use to decide it is if the length of the string is even or odd, but that is not necessarily the case. Whatever string kind you have, you need to perform both scenarios where the left and right start from the same position, or they do not start from the same position, they start from a position apart, and then spread it out to see if you can get palindromes out of it. So let's go and see how we can get that solved. So here, let's write the function to get palindromes. So get palindrome. We have the left, the right, and the string itself. So Results is equal to 0 at this point, while left is greater or equal to 0 and right is less than the length of s, and s at left is equal to s at right. Then we have a palindrome. So we increment results by 1, and we shift the left pointer back and then the right pointer forward. Okay, after that we return results. Now the answer is going to be 0 at this point, and for I in range, now we're going to do the loop, length of s. Answer is going to be get palindrome for I when the left and right start at the same position, and then we also check and add for when the left and right start from 1 ports apart. And then we return the sum of all of that. So this is just a function to identify palindromes. This is looping through and applying and getting the counts. We'll see. Yep. Thank you for watching. See you in the next one.